Docker and Kubernetes. You've seen these two words everywhere, in job posts, in tutorials, in every DevOps roadmap. But what are they really? And why does everyone act like you must know both? In the next few minutes, you'll understand both, not as buzzwords, but as tools that solve real painful problems. No prior experience needed, just follow along. Let's start with the problem. A developer writes some code. It runs perfectly on their laptop. Everything works. They're happy. Then they send it to the server, and suddenly it breaks. Errors everywhere, the exact same code. So what happened? The problem is the environment. The laptop and the server have different versions, different libraries, different settings. The code is the same, but the world around it is not. So engineers asked a simple question. What if we could package the code together with its entire environment and ship the whole thing as one unit? That package is called a container. Think of it like a lunchbox. Inside, you've got the app, its libraries, the runtime it needs, and the configuration, everything sealed together. Because the container carries its own environment, it runs the same way everywhere. Your laptop, a test server, the cloud. No more, it works on my machine. It works the same everywhere. This is exactly what Docker does. Docker is the tool that builds these containers and runs them. It's the most popular way to put your app in a box. An image is the blueprint, a frozen snapshot of your app and its environment. A container is what you get when you run that image. One image can start many identical containers. You make an image with a small file called a Docker file, a simple list of steps. Start from this base, copy my code, install these libraries, run this command. And the best part, anyone on your team runs the same image and gets the exact same result. No setup nightmares. That alone made Docker a game changer. For full stack, cloud, and DevOps explained simply, follow Shadhin path. In the next part, we'll see Docker run a real app and why it still isn't enough. Let's make Docker real. A typical full stack app has three parts: a front end the user sees, a back end that does the logic, and a database that stores the data. With Docker, each part runs in its own container. Your React front end in one, your Node or Flask backend in another, PostgreSQL in a third. Clean, separate, independent. Starting 3 containers by hand every time gets tedious. So, Docker has a helper called Docker Compose, one file that describes all your containers and starts them together with a single command. Now your whole app spins up in seconds. Front-end, back-end, database, all talking to each other. This is where most developers fall in love with Docker. But then you launch to real users, and a new set of problems appears. Problems Docker alone doesn't solve. Problem 1. A container crashes at 3 in the morning. Who restarts it? Something needs to watch your containers and restart them automatically. Problem 2. Traffic explodes. One container can't handle 10,000 users. You need 10 copies, or 100, spun up instantly and shut down when the rush ends. Problem 3. You're now running containers across many servers. Which container goes where? How do they find each other? Managing all this by hand is impossible. This is the exact problem Kubernetes was built to solve. If Docker runs a single container, Kubernetes orchestrates hundreds of them across many machines automatically. A node is just a machine, a server that runs your containers. Many nodes together form a cluster. Kubernetes manages the whole cluster as one. Inside the cluster, Kubernetes runs your containers in little wrappers called pods. A pod is the smallest unit Kubernetes manages, usually one container doing one job. You don't tell Kubernetes how to do things step by step. You tell it the goal. I want 5 copies of my app running, always, and Kubernetes makes it true. That idea is called the desired state. You describe what you want, and Kubernetes constantly fixes any difference. It's like a thermostat for your app. For full stack, cloud, and DevOps explained simply, follow Shadhin path. Next, we compare Docker and Kubernetes side by side. Let's see Kubernetes in action. Self-healing. A pod crashes, Kubernetes notices instantly and starts a fresh one. No 3 a.m. wake-up. It just heals itself. Autoscaling. Traffic jumps. Kubernetes adds more pods. Traffic drops, it removes them, so you only pay for what you actually need. Rolling updates. You ship a new version with zero downtime. Kubernetes swaps pods one at a time, and if something breaks, it rolls back. Your users never even notice. So let's put them side by side. They are not competitors, they work together. Docker is about a single container. Kubernetes is about running many of them in production. Docker builds the container and runs it. Kubernetes organizes, scales, monitors, heals, and updates many containers across many servers. Here's the analogy that makes it stick. Docker is like packing a meal neatly into a delivery box. Kubernetes is like running the entire delivery company, hundreds of orders, drivers, and routes, all on time. So what should you learn first? Always Docker. Build an image, run a container, get comfortable. Then Docker Compose to run a few containers together. Only after that, move to Kubernetes. If you're building small apps, Docker may be all you ever need. Don't rush to Kubernetes before you need it. But if you want a career in DevOps or cloud, Kubernetes is essential, one of the most in-demand skills in tech today. Quick recap. The problem: code breaks across environments. Docker packs your app into a container that runs the same everywhere. Kubernetes manages many containers in production, healing, scaling, and updating. That's Docker and Kubernetes, explained simply. If this finally made it click, follow Shadhin path for full stack, cloud, DevOps, and AI, all explained this simply. And tell me in the comments what I should break down next.